Hello viewers, welcome to another lesson for the senior secondary school category. Remember, we are still on trigonometric 1, and the lesson for today is special angles of triangles. I know some of you might wonder why the name special angles of triangles, but it's moreover like the same thing you've learned in the previous lesson. Now in this lesson, the values of special angles that we are going to look into are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. These are the special angles that we will look at in this lesson. Now to read what we have on the board, recall in geometry the study of special cases of right triangles such as 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. The angles associated with these triangles occur frequently in trig, and so it is important to learn and remember the exact values of these functions. In the previous lessons, you were told the meaning of the word trigonometry. It is a word comprising of 3 syllables. The first syllable there is tri. And what is this tri? In Latin, it means 3. The gono, from the Latin gonia, refers to the angular, and here we refer to the angle. And metri, from the Latin metron, refers to what? Measurement. In short, these 3 syllables combine to form the word trigonometry, meaning triangular measurement. So here, this is the lesson purely, in short, like I've just explained. And like I said in the previous lesson, the teacher has already told you the meaning of these trigonometric ratios. Now the first part of the lesson would be evaluating trigonometric functions of 30 degrees and 60 degrees without using calculator. If you use your calculators to punch each of these functions, obviously you will get numbers. But here now, in this discussion, we are going to see how can we use the concepts of right angle triangles under the concept of trigonometric functions to see how best we can obtain each of these values. To do this, we are going to make sure that we consider an equilateral triangle. What is an equilateral triangle? An equilateral triangle is a triangle that has all its sides equal and all the angles equal. The value of each angle of an equilateral triangle is equals to what? 60 degrees. So since a triangle has 3 sides and 3 angles, so it means each of those angles must be equals to what? 60 degrees. Now looking at the triangle that we have on the blackboard, labeled A, B, C, with a perpendicular line that bisects line AB at 90 degrees, labeled as CD. All the sides are equal. So we are going to use this triangle together to help us find the trigonometric functions of 30 degrees and 60 degrees. Now, what are going to be these trigonometric functions inside? Remember in your previous lesson, your teacher have taught you how to remember these trig ratios using the acronym SO, CA, TUA. And I believe he further went on mentioning the reciprocals of each of these ratios. So these are the components that we are going to look at today. And remember, the theme is evaluating trigonometric functions of 30 degrees and 60 degrees without using calculator. Can we do that together, please? Using the figure that we have on the board. Now, like I said, we are going to consider an equilateral triangle. And I already told you the meaning of an equilateral triangle. The triangle we are going to consider is going to be of this form, where this angle is A, B, C. So since A, B, and C, triangle ABC is an equilateral triangle, so it means all the sides are equal. In the same triangle, I would like to draw a perpendicular line from C to bisect line AB at 90 degrees. And that will give us a shape like this. So we label this point as D. Now, if you look at the shape that you have on the board, it means we are able to bisect or divide triangle ABC into two equal right-angled triangles. So the two triangles, triangle ADC is equal to triangle BDC. They are all right-angled triangles. From the figure, let's take the dimension of line AB from this point to this point to be 2A. If the distance from A to B is measured 2A, what will be the measurement to line BC and line AC? Looking at the shape, we all agree together that we are solving this using what? An equilateral triangle. So if line AB equals to 2A, we can conclude by saying line AB must be equals to what? Line BC must also be equals to line AC, equals to 2A. Why are these three sides equal? Remember I said it is an equilateral triangle. And in an equilateral triangle, all the sides must be what? Equal. So therefore, this side will be 2A, and this other side also must be 2A. Since we are able to find all the sides of the triangle using the concept of equilateral triangle, what next are we supposed to do? Remember, our target is to find the trigonometric functions of 30 degrees and 60 degrees using an equilateral triangle. So from this equilateral triangle that we have on the board, we can show certain relationships that can help us to get that. And what are these relationships? We stated that triangle ADC is equals to triangle BDC equals to what? A right angle triangle. Again, we can say that angle A Now we can show other relations from the same equilateral triangle by stating that angle A is equals to angle B equals to angle C equals to what? 60 degrees. Why are these three angles equal? Again, we stated that the value of each angle in an equilateral triangle supposed to be equals to what? 60 degrees, and the sum of all the three angles added all together will give us 180. Again, we should know that from the same triangle, if you look at line CD, we can say line CD bisects line AB at what? 90 degrees. They are perpendicular. And also, line AD is, okay, the line segment CD is perpendicular to line. Thank you. Since we are able to tell that angle A equals to angle B equals to angle C equals to 60 degrees, also the line segment CD is perpendicular to line AB, which is a right angle. From the same diagram, we can see that line AD equals to line BD equals to half times line AB. Meaning, the perpendicular bisector, which is line CD, is able to what? To divide line AB into two equal halves. So from the diagram, if line AB is 2A, it means from here, we can simplify by saying that half times 2A. So if you simplify this, 2 can cancel 2, and we are left with what? 1 times A will give us A. So we can conclude by saying that line AD, since it is equals to BD, each of these two dimensions is going to be A, and this point also must be what? A. From what we have just stated. Now to move on, we can now go and then find the perpendicular line that bisects line AB. And that is a common height to the two triangles that we mentioned earlier on, which are triangle ADC and triangle BDC. Now to find that line, what are you going to do? Remember, in your previous lesson, you are told how to use the Pythagoras theorem to find a missing side from a given right angle triangle. And here we are told that the right angle triangle on the right hand side is the same and equal to the right angle triangle on the left hand side. We said they are said to be congruent. Now using any one of them, since the height is common, will give us the same result. So in this case, I am going to use triangle ADC. Let's consider triangle ADC. We label this side as 2A, remember? This was A. And remember, this is a right angle at D. If you look at the previous diagram I drew, this is where we extracted this from. But our target is to know the line segment that bisect line AB at right angle, which is line CD. So like I said, in our previous lesson, your teacher told you something about the Pythagorean theorem. And what does the Pythagorean theorem state? It states that the hypotenuse squared equals to the sum of the other two sides all squared. Now in this case, we have a right angle triangle. And I believe the teacher also has made mention of how to identify these sides. That's your hypotenuse, the adjacent, and the opposite. Great emphasis was laid about these three sides. I will remind you again. The side opposite to the right angle is always your hypotenuse. To determine the adjacent or the opposite, you have to be given an angle. Where the angle is located now will determine which side is supposed to be the opposite and which side is supposed to be the adjacent. In this case, can you see any angle given apart from the 90 degrees? No. Okay. Assuming from this right angle triangle, I have chosen this angle here to be theta. Which side will be our opposite? Obviously, this side will be the opposite. And line AD labeled as A will be the adjacent. So we are going to use these three parts or three sides of the triangle to find the line CD. Let's move on. So assuming the opposite is labeled X, and this side is already known as A, that other side is known as 2A. The Pythagorean theorem states that the hypotenuse squared must be equals to the sum of A square plus, this side is not known, I want to label it as X square, where X is our variable to determine. 2A squared, all in bracket, is the same as 4A square, because the square outside the bracket is affecting everything in the bracket. So you need to take note of that, which is equals to A square plus X squared. If you look at the equation given, we can identify something there. What can you identify? There are like terms. And what are these like terms? 4A square is a like term to A square. So we are going to collect them to further simplify to help us get the value of X. 4A square, if you transpose A square to the left-hand side of the equation, will give us minus A square equals to X squared. What is 4A square minus A square? The coefficient of A square is 1. Subtracting 4 minus 1 will give us 3A square equals to X square. Our target is we want to know the value of X. In our last lesson, remember, you were told that to know the side that you are asked to calculate, once it is affected by a power of 2, you can always take the square root of both sides. And that will give us the square cancel the root. And here, remember, mistakes are always done by students when they are simplifying things like this. There is an operation combining the 3 and A square. And what is that operation? It's multiplication. So the square again is affecting only the A and not the 3. So this could mean the same as root of 3 times, remember dot could also represent multiplication, the root of A square equals to X. In short, you are told something like this. The square can always cancel the root. So you are left with what? Root of 3 times A is equals to X, which means our opposite side is equals to root 3 times A. Now, since we are able to know the height of the isosceles triangle, I can draw it again here, and we saw in all the values that will help us to indicate the trigonometric functions of 30 and 60 in our table. We are going to get our diagram like this, where this angle is A, this is B, and this was C. Then this is D. Remember we said this angle is 90. This was A, and this side was given as A from what we calculated. We knew that this is 2A, and this was 2A. So the line that we calculated was line CD, and the answer we obtained there was root 3 times A. So we are able to get all the parts that we need that will enable us to calculate the trig functions of 30 degrees and 60 degrees. Remember, it's an equilateral triangle. So each of the angles supposed to be equals to what? 60 degrees. This angle also must be 60 degrees. Now, there is one more thing that I did not mention before we start the work proper. And what is that? That thing I want to mention right now is looking at the angle at C. Remember, we said angle A equals to angle B equals to angle C, and equals to what? 60. But when I bring in the line segment CD that bisect line AB at 90 degrees, the angle at C is no more 60. What should be the angle if it is not 60? Since the angle is bisected, we can now say that each of these angles will be 30 degrees each, because the 60 has been bisected. Now we are able to tell from our diagram angle 30, angle 60, and angle 90. If you add in triangle ACD or ADC, the sum of angles in that triangle will give you obviously 180. In the right hand side also, triangle BDC, if you add all the angles inside the triangle, you will equally have 180 degrees. And this proves that all of them are fit to be what? Triangles, since the sum of angles in a triangle add up to 180 degrees. Now to move straight to the point, this angle we said is 30. This one also must be 30. This is 60, this is 60, and this is a right angle. This place also must be a right angle. So we start with the force trig ratio, which is sine. Remember, so I start with sine 30. Remember, using the trig function so is sine theta, and theta is 30. You can take any of the triangles, it will give us the same result. So sine 30 from triangle ADC is going to be equals to the opposite of the angle. You can see directly on the board, the side opposite the angle 30 is what? Is A. We put A all over. Remember, sine equals to opposite all over the hypotenuse. Where is the hypotenuse of this triangle ADC? Obviously, the side facing or opposite to the right angle is 2A. So we put that as the hypotenuse. We have A over 2A, can further be simplified. This is the same as cancelling the like terms. A into itself is 1, into A here is 1. So that will give us 1 over 2. So if you punch the function in your calculator, sine 30 right away, the calculator will give you 0.5, or in other words, it will give you 1 all over 2. And we have right away proven to you how this is possible from the calculator. So all the two numbers are correct. I want to use sine 60. Let's see what that will give us. The same function, remember, sine equals to opposite all over the hypotenuse. And this time around, we are considering 60 as the angle under consideration. So what is going to be the opposite to angle 60? Looking at the angle, it is opposite to what? Line CD. And that is giving us root 3 times A all over what is going to be our hypotenuse. The hypotenuse still remains as 2A. Again, if you compare these two, there is something that can be cancelled. And what is that? A is common to both the numerator and the denominator. Obviously, they can cancel. And that is going to be equals to root 3 all over 2. Again, if you punch this from your calculator, in some of the calculators we have different types, although, I do provoke students, those with FX990 and FX991. So if you have the FX990, perhaps it will give you a decimal, and the decimal form of it is going to be 0.866666. You can round it up to 1 decimal place or 2, and that could be to 2 decimal place, you will have 0.87. Okay? Or if you want to leave it in short form, that's exactly what you are going to get, and that will be √3 all over 2. If your calculator cannot express it in that form. In decimal form, could be 0.8666, like I mentioned. So if you want to write it to a required number of decimal places or a required number of significant figures, it depends on what the tax given to you is. But all these are possible, I am putting to you. Now, from the sign, the next function I want us to look into is cos. I go back to 30 again. Cos 30 is equals to, remember the word cos, K, from the acronym, K, C-A-H. C is cos, A is adjacent, and H is hypotenuse. So if cos 30 is the angle under consideration, what's going to be the adjacent of this angle? I am still considering triangle ADC. The adjacent of cos 30 is going to be what? √3 times A. So we put √3 times A all over. The hypotenuse remains as what? 2A. So since they have something in common, A will cancel A, and this is equals to √3 all over 2. So by comparing something here, I want us to look at the value of sine 60 and cos 30. What can you say about the two? I have sine 60 equals to √3 over 2, and cos 30 equals to √3 over 2. What can you say about the two? From what we can see, we can conclude by saying that sine 60 equals to cos 30, which is very true. Now, let's take the next one and see whether the value of cos 60 could be compared to something as well. Now, if you look at the diagram again, we want to consider 60 this time around from the same right angle triangle, ADC. Cos 60 equals to the adjacent all over the hypotenuse. What is going to be the adjacent to this angle? The adjacent to angle 60 is going to be A. We put A all over. What would be the hypotenuse? The hypotenuse is going to be 2A. Wow. Comparing the numerator and the denominator, do they have anything in common? Yes, they have. And what is common between the numerator and the denominator? A is common to all of them. In this case, we cancel, remember. A into itself is 1, into A here is 1. So our fraction is going to be 1 all over 2. Again, I want to ask this question. Is there any relationship between cos 60 and sin 30, class? I repeat my question. Is there any relationship between sin 30 and cos 60, or cos 60 and sin 30? Remember, sin 30 equals to 1 all over 2 from what we did. It's our work. We did it together. And cos 60, again, we are able to solve and we get 1 all over 2. What can you say about the two? We can conclude by saying that cos 60 is equals to sin 30 equals to 1 all over 2, which is also a true statement. So here you can tell that there are some relationships at some point in time when dealing with trigonometric functions. Now, to move to the third trigonometric ratio, which is tan, I start with tan 30. Remember from the acronym TOA, T-O-A, where T is tan, O is the opposite, and A is the adjacent. And we said tan theta equals to opposite all over the adjacent. I go back to the same right angle triangle, ABC. The angle under consideration is 30. And the opposite to 30 is what? A. So we give A over. Adjacent to 30 is going to be what? Root 3 times A. A into itself is 1. Into A here is 1. So the answer you are going to get for tan 30 is going to be 1 all over root 3. If you want, you can stop here as your answer. And in some calculators, if you press equally, you are going to get a decimal value, and the value is going to be the same as 0.577. And if you want to round up this number perhaps to 1 decimal place or to 2 decimal place, I will want to round up to 2 decimal place, you are going to get 0.58. But others prefer solving this further. You did sorts, right? Where you were taught how to rationalize. If you want, you can further rationalize this, and that will give you 1 all over root 3 times. To rationalize, you take the denominator, which is in a radical form, and multiply both by the numerator and the denominator. If you do that, you are going to have 1 times root of 3 will give us root of 3 all over. Root of 3 times root of 3 obviously is going to give you the square root of 9. And the square root of 9 is the same as 3. So the answer to tan 30 could be expressed as 1 all over root 3, which is the same as 0.58 to 2 decimal places, or you can also express it as root 3 all over 3.